What's up, my statisticians? This is Professor Sampson from PS I Love Math back with another statistical banger. I love doing these videos. Sometimes it's tiring, but math is wonderful. Math is fun. So, but not all the time. But anyway, so what are we going to be doing today? Well, we're still on our series of two samples, working with two samples. We're doing two sample confidence intervals for this so-called series. So now we're going to be doing a two sample confidence interval where sigma is unknown. And you have to know that when the sigma is unknown, then that's the population standard deviation is unknown, you're going to use what? A t-test. So it's similar to the last video, but don't get out of there. Please stay to the end. All right, so you can see the problem work through. It always looks good when I work it, but try to stop the video, work it yourself. Stop in the middle. I'll give you some places to stop and do that. Anyway, as usual, it's a YouTube channel. Please like and comment. It will support me so much if you watch my videos and you comment. And definitely subscribe. My channel is on the rise, right? I'm trying to make it to 1,000 views, 1,000 subscribers, or whatever that means. Not like I'm going to quit my full-time job to be a YouTuber, but it would be nice to get 1,000 subscribers. Okay. So anyway, let's move on. And as usual, I'm going to share my screen and we're going to get started with this stuff. Okay. So let's see what our problem is talking about today, all right? So today our problem is saying a researcher is interested in exploring the relationship between calcium intake and weight loss. Interesting. Two different groups, each with 25 dieters, are chosen for the study. Group A is required to follow a specific diet and exercise regimen and also take 500 milligrams supplement of calcium each day. Group B is required to follow the same diet and an exercise regimen, but with no calcium supplement, right? After 6 months on the program, the members of Group A had lost a mean of 12.7 pounds with a standard deviation of 2.2 pounds. The members of Group B had lost a mean of 10.8 pounds with a standard deviation of 2.0 pounds during the same period. Assume that the population variances are not the same. Create, then interpret a 95% confidence interval to estimate the true difference between the mean amount of weight loss by dieters who supplement with calcium and those who do not. Okay, so they're telling you dieters who supplement with calcium and those who do not. So we're going to start with the dieters who supplement through calcium, or simply Group A, as we want to call it. So we want to start there. Okay, so you know which one to use as the first one. Okay, so as you know from working with me, you go through and you look for the numbers, right? They got 25 dieters, Group A, and then you go through the thing. Group A, 12.7 pounds with a standard deviation it is. All right, so we need to know before we can start whether, and I gave it away in the intro and in the title of the video, but we need to know whether we're talking about a standard deviation is known or population standard deviation is known or unknown. But anyway, right here, I always write Group A so I can keep a balance of what I'm talking about since I have two samples, and Group B. All right, so as we read, we know that N1 for Group A is going to be 25 because they both had 25. All right, so N2 is actually 25 if we want to write it. All right, but Group A had a mean of 12.7 pounds. So mean, what can we use for mean? Well, mean is X bar, and what's the other one for mean? Mu. But this is the mean of Group A of that sample. So we're going to use X bar is equal to 12.7, right? And then we're going to use the standard deviation of that sample is S is going to be 2.2. And when we read on, just to keep this a little shorter, but you can always stop so you can guess it yourself, of course, X bar for the B group is 10.8. And then their standard deviation is 2.0. Okay, and we're looking for a 95% confidence level. So I'm gonna put alpha is equal to what? 0.05. Right, we should already know that if we're into two 2 samples as opposed to 1 sample. Right, so I think we got just about everything that we need here. So we know we're talking about samples, and we know that we're talking about mean. So we need to find out, okay, what formula are we going to use? And hopefully, I'm sure that your instructor will give you a formula card or something of that nature where you can pull out the formula. But as you know from watching me, I have a formula sheet down here that I might pull up every now and then just to show you. Is it here? And here's the formula, looks like right here. We're looking for the confidence interval for the difference between 2 means with independent samples. All right, 2 sample confidence intervals. So this is the long thing. And what you want to take a look at is the fact that in this video, it's T alpha over 2 as opposed to Z alpha over 2. Why is it a T? Because the population standard deviation is unknown. I cannot specify that anymore, and I'm sure that even if I'm not your instructor, if you're looking at me on YouTube, you know, you will know that your instructor should specify that. I'm sure they're going crazy with that. So the formula is this: E minus mu 1 minus mu 2 is less than x bar 1 minus x bar 2. And then that's going to be plus E. So we have our X bars, and we're going to look for our E in a minute. So if we take our X bar 1 and X bar 2, I'm going to do it over here. Last time I did it differently. But X bar 1 minus X bar 2, right, that's going to equal to 12.7 minus 10.8, right? And as I said, do not be afraid to use your calculator. That's what you have it for. You didn't pay for the calculator to not use it. I know my students think I say don't use it, but I say don't use it for the shortcuts. You can use it for basic addition. So that's 1.9. So your X bar 1 minus X bar 2 is 1.9. And then you're going to have minus E. Again, you might want to check with your particular instructor for how much you need to write. My students know they need to write this much so they can get credit. So what is E equal to? E or M, depending on your book, they may call it different letters, but it's really the margin of error. That's all it is. So the margin of error is T alpha over 2 times the square root of S sub 1 squared over N sub 1 plus S sub 2 squared over N sub 2. Okay, so that's the margin of error. So let's get started. Where our T alpha over 2, remember T is 0.5, so alpha over 2, again, don't be afraid to use your calculator. See, I have my hand calculator if I don't want to pull it up on the screen, just to make sure that you double check your 0.05 divided by 2 is 0.025. So your alpha over 2 is 0.025. Right, 0.025. So that's what you're looking for. You're looking for T of alpha over 2 or T of 0.025. Right. So let's go find our T of 0.025. Now T, the T chart, we need a what as opposed to the other chart. Let's pull it up. So for our T chart, right, we need degrees of freedom. In my class, there's several ways to get degrees of freedom. So you might want to check with your instructor. If I'm not your instructor, there are several ways. There's the way that the calculator does it that gives you a number. There's a way that you combine, you add N1 and N2 together. But I do the basic way, which is we're going to take the lower of the N1. So the degrees of freedom is N minus 1. So we take the lower of the two, so 25 minus 1 is 24. It just so happens that these have the same amount of N. The N's are the same. So if they weren't, you would take a different number. But so we have 24, and we have alpha is equal to 0.025. So let's go back to our T chart. We see 0.025, and we need to go down to 24. Zoom out a little bit. Here's 24. And there's 0.025. 0.025. There you go. All right. So as you can see, I highlighted it there. I don't know if you can see it, but let's move it up and make it bigger. All right. So that's going to be 24 and 025. If you go up to 025, as I showed you, that's 2.064. So let's write that down. So now your T alpha over 2 is 2.064. The square root. Now you just need to plug in all your numbers. If you're in my class to get credit, 2.2 squared over 25 plus 2.0 squared all over 25. Now you can use your calculator because I know you know where the numbers are, and I know that you would know exactly what to do if you had to do it by hand, okay? So we're going to use the calculator here and see what we come up with. So let's pull up our calculator again and go through the work in the calculator, all right? So where do we go? So the first thing we do is we think of what class we in. We go to stat, and then we go over to test. And what kind of test this is? This is a 2-sample interval test, but it's a t-test because you don't know the population standard deviation. Now I can go down or go up. I know it's not the number 9 because the 9 is a 2-sample z interval. All right, I'm looking for a 2-sample t interval. Okay, just so you know the difference, I'm actually going to go up, and there it is, 2-sample t interval. All right, and of course we don't have data in this one. I should have done one with data. If you want one with the data, please comment down below and let me know you want me to show you one and walk through one where you're given actual data instead of statistics. Please comment down below. Let me know what you think. All right, let me know that that's what you need, and I'll create another video. So then we're going to go through these numbers, and as usual, I'll put these numbers in a second, and then I'll come back with the numbers in because I don't need you to watch me put in the numbers and make the video longer than it should be. Okay, so the numbers are all in, as you can see. I'm sure you put the numbers in. Pause the video and put it in here. I always stop here so you can see it. I think they said 0.095. Let's just make sure. Yeah, it was 95 because our alpha over 2 was 0.025. 0.95, and then no to pooled. You'll know what pooled mean by your instructor. I'm not going to explain what pooled and not pooled is, but it's no for this one. And then we're going to calculate. All right, and we're going to see what we get here. So we're going to write it down properly. Now, again, your instructor may decide to do it differently. I don't do it. My students have to write the full thing out to get credit. They can't just write this parenthesis with all those numbers. All right, so let's go back to here, and your instructor may be the same way. Okay. Now, I didn't just put E, all right, there. I'm going to add this x bar 1 minus x bar 2. I just wanted the students to tell me, you know, that they knew where the numbers went. So we're going to write our final answer here that we got in the calculator, and that's going to be 0.7, I believe. So 0.7. And why did I use 0.7? Because the x bar that was given that I'm adding and subtracting from it already was just 1 decimal point. So I'm not going to change that. I can't be more precise than the data that they already gave me. Okay, and let's check the other one real quick. 0.7, and that's 3.1, because that 09 you got to round up, so 3.1. Okay, and that's your confidence interval. So depending on your instructor, they may want you to write a lot because it says create and interpret. So I created the confidence interval, and now I need to interpret it. So interpret what we're given, and you know I always type these out. So interpret. So this is my interpretation. All right. What is the interpretation, right? We are 95% confident. Always start off with that. We are 95% confident, right? What are we 95% confident of? That the mean amount of weight loss right, by dieters who supplement with calcium, because that was our A, who supplement with calcium, what is between, right? And then this is when you put in your confidence interval, is between 0.07 and 3.1 pounds. What? We are 95% confident that the mean amount of weight loss by dieters who supplement with calcium is between 0.7, and I put that wrong. Let's go back. Right? Make sure it's right. Is 0.7 to 3.1 pounds what? Greater than, right, the mean amount of weight loss, right, by dieters who do not. Calcium supplements, right? Okay, so this is your interpretation of what you just put down, okay? So your interpretation is here, that you are 95% confident that the mean weight amount of weight loss, because it says create and interpret a 95% confidence interval to estimate the true difference between the mean amount of weight loss by the dieters who supplement for calcium and those who do not. So you're really just copying up there. The mean amount of weight loss by dieters who supplement with calcium is between 0.7 and 3.1 pounds greater, right? Because that's positive. It would be less if it was negative, greater than the mean amount of weight loss by dieters who do not take the calcium supplement. And I just want to make this correction because I'm sure I'll get it in the comments. You spelled calcium wrong. I'm like, really? All of that? And that's what I get. I spelled calcium wrong when I was typing it in. Well, I can't seem to get it out right now, so it's not going to work. But anyway, you get the point. So that is the interpretation of the answer or of the problem and the work, and showing also both that you know where the numbers go. Let me stop sharing screen. You can always go back. But and showing both that you know where the numbers go, and then also using the technology to further do all the mathematical calculations. So remember, that's what you're supposed to be doing. You're supposed to be doing both of them hand in hand, not just having the calculator just spit out the numbers and you write down all the numbers and can't round or do anything. I'm sure that all instructors would agree with that. So that's about it. So please don't forget to like and comment, definitely, but also subscribe to my channel, because you know I'm on the road to 1,000. But subscribe to my channel and also tell me what you think. Give me some comments about the video. So that's about it. This is Professor Sampson from PS I Love Math, and I was blessed.